Now, the value of a lathe originally valued at 3,000 depreciates 15% per annum. Calculate its value after 4 years. And then the next part will be the machine is sold when its value is less than 550. After how many years is the lathe sold? Right, so let's just look at the first bit first. Calculate its value after 4 years. Right, what does this mean? 3,000. It starts at 3,000, right? Starts off at 3,000 euros. And after 1 year, it's worth 15% less. Right, 15% less. So that means that 15% of the value fell off this after 1 year. So another way of looking at it is that after 1 year it was worth 85% of its original value after 1 year. Okay, and 85% is the same as 0.85. So after 1 year, 3,000 multiplied by 0.85 will give us the value of the lathe. That's the lathe after the value of the lathe after 1 year. 3,000 multiplied by 0.85 gives us 2,550. Right, that's it after 1 year. That's the end of year 1. And then to get it at the end of year 2, we'd have 2,550 multiplied by 0.85 because the depreciation is steady, it's per annum. So at the end of the next year, it'll be worth 85% of 2,550. And that's 2,167 and 50 cents. Right, and at the end of the year again after that, multiply that by 0.85 or get 85% of it. Same thing really. So 2167.5 multiplied by 0.85 gives us 1842. To the nearest cent, it's 0.38. So that's at the end of year 1. End of year 1, right? E1 for end of year 1. End of year 2. End of year 3. After 4 years then it'll be the end of year 4, won't it? I think it will. That's 1 year done, 2 years done, 3 years done. So 1842.38, getting 85% of that. Multiply by 0.85, and we get 1566.02. So after 4 years, the value will be 1566.02. That's the value of our lathe after 4 years. Now I think we could also have done that using the formula in the back of the exam sheet from the geometric progression formula, right? And that was to get any term, you use AR to get the nth term n minus 1. Now in our case, the term was the fourth term. Let's try that. So if n equals 4, A is our starting amount, 3,000, right? And R is the common ratio. It's the multiplier. You know, the multiplier in this case is going to be 0.85. So the fourth term will equal 3,000 multiplied by 0.85 to the power of n minus 1. So that's 4 minus 1. So that's going to be 4 minus 1 is 3. I'm not sure if that's going to work out. 3,000 multiplied by 0.85 to the power of 3. We already did it 1, 2, 3, 4 times, didn't we? Let's think about that now. 3000 multiplied by 0.85, use the power key to the power of 3, and I get 1842.38. That's euros. So after 4 years, you see the first term really, the first term is 3,000 euros. The second term, that's n equals 1, n equals 2, 3, 4. I'm confusing myself now. So it's 3,000, 2550, 2167.5, 1842.38. See, after 1 year it'll be worth this. After 2 years it'll be worth that. After 3 years it'll be worth that. After 4 years. After 4 years, you're looking for the fifth term. We were talking about after 4 years. There's going to be 4 years of depreciation anyway. So it's going to be this R 0.85 to the power of 4. So n will be 5. So the answer I'd be sticking with, I hope it's not too confusing, the answer would be this one here, right? 1566. That'll be the value after 4 years. After 1 year, that's the value. After 2 years here, after 3 years here, and after 4 years, that'll be the value there, 1566.02 euros. And you can filter around with this equation or formula here as well if you want to do it that way. Right, next up, the machine is sold when its value is less than 550 euros. After how many machine years is the lathe sold? So it'll be sold when AR to the power of n minus 1, when that is less than 550. That's when it's going to be sold, right? Because this formula here gives us the term, gives us the amount, that the worth of this machine after a certain amount of years. We want to know what n is, right? Let's switch to black there. So A is still going to be 3000. R is going to be 0.85. And the only thing we don't really know is n. So we're trying to figure out what n is going to be to make this whole line of stuff here true. So now I'm going to divide both sides by 3000. So I'll have 0.85 to the power of n minus 1. And I have 3000, I can write it in there still. I'm dividing all that side by 3000. So in order to keep things true in the universe here, we must divide both sides by 3000. So the 3000s will cancel here, and we're left with 0.85, or 0.85 I suppose, doesn't really matter, less than 5 over 3. What's 5 over 3? Well, we can leave it as 5 over 3. Oh, sorry, that's 550. So we have 550 divided by 3000. We get 11 over 60, which is, we can leave it as 11 over 60 actually. Makes things handier than dealing with recurring decimals, right? So what did I get there? 11 over 60. Now what are we going to do? 0.85 to the power of n minus 1 is less than 11 over 60. So if 0.85 to the power of n minus 1 less than 11 over 60, how are we going to solve this for n? Well, when you have a little power thing going on like this, usually logs is the answer, so we'll take the log of both sides, right? So we can say that the log of 0.85 to to the power of n minus 1 is less than the log of 11 over 60. And we can look up both of these. Well, no, first of all, the log, this structure on the left, we can rewrite that as n minus 1 times n minus 1 in brackets times the log of 0.85 due to the law of logs. This here equals that. It's just rewritten. We can float the power down in front like that. That's less than the log of 11 over 60. Now we can look up these two logs, do them on the calculator to turn them into more friendly looking numbers if you like, right? Look up the log of 0.85 on the calculator, or calculate on your calculator, and we'll have n minus 1. The log of 0.85 turns out to be minus 0.0706, right? Less than, and when we put the log of 11 over 60 through the calculator, you should get minus 0.7368. That's rounded now. Both of those are rounded to 4 decimal places. So now we're going to divide both sides by minus 0.0706, right? Now, when you have an inequality like this, it's not an equal sign, it's an inequality, it's less than. If it was a less than or a greater than, they're both inequalities. And when you're dividing across by a negative number with an inequality, we have to flip this guy. So now we can write n minus 1 is greater than minus 0.7368 over minus 0.0706. And dividing this guy by that guy will give us a positive number. We have n minus 1 will be greater than, run that through the calculator and you should get greater than 10.43. And now I'm going to add 1 to both sides. n minus 1 plus 1 leaves us with n greater than, and I'm just adding a positive 1 to both sides so the inequality stays the same, and we get 11.43 there. So n is greater than 11.43, right? N is going to be a whole number, it's a number of years. So n equals 12. N equals 12. And if we think about the number of years, to get down to a figure less than 550, we're using AR to the power of n minus 1. And you see that'll be 12 minus 1. So that'll be AR to the power of 11. So the answer is 11 years. And we can try and solve it. You can run it through. You can actually get your A, so it's going to be 3000. We can try it out, right? Try out 11. So you have 3000 is A, multiplied by R is 0.85, and n minus 1 is 11, so that's 0.85 to the power of 11. Run that through the calculator, and you should get 502. Now, sorry about the wee mess here, but if we keep A as 3000, R is 0.85, and work out this little calculation here, you'll get approximately 502 and change, right? Something like that. So the answer is 11 years. It's a bit sloppy, but hopefully you get the idea.